Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled A Martian Eclipse. Phobos crosses the sun. So what do we see here? Well, here we see the sun in the sky, and not from Earth, but instead from the planet Mars. And this was taken in 2022 by the Perseverance Rover, looking up at the sky and watching as Phobos would pass in front of Mars. Now I'll play this in just a moment and we'll look at it. But what we're going to see is an eclipse, much as we see here on Earth, except that Phobos does not appear large enough in the sky to completely block out the sun. So let's go ahead and play the video and we'll watch as Phobos enters from the upper right side there, and we'll see it as it begins to move into the sun, and we can see it now as it's moving across. Note that it's a different shape than our moon. It's not completely spherical. That's because of its much smaller size, only about 12 kilometers across, much smaller, I should say, than our own moon. But it's also a lot closer to Mars, making it appear still relatively large. So we see it now as it's disappearing down toward the bottom of the sun there, and it will slowly disappear off as the video ends. And we'll repeat it so we can take a look at that as it goes. But when we watch this, we have to realize that we're watching this in real time. This is exactly how long this eclipse took. And that's because Phobos moves much faster than our moon. It's a lot closer to Mars than our moon is to us. And it moves therefore a lot faster. So only 40 seconds worth that it took from the time the eclipse starts until it ends. Now that's much shorter than an eclipse would be here on Earth. It takes a much longer time for our moon from the time it starts blocking out the sun to move all the way across the other side and finish the eclipse. The total eclipse in many cases is much longer than the 40 seconds of the complete eclipse here. Now Phobos does, as I said, orbit very close to Mars, and it's actually in a decaying orbit and will eventually either be torn apart by Mars's gravity or crash into Mars at some point in the distant future. We're still talking many millions of years from now. But it's not going to be there forever. So eclipses like this we get to see right now, but will not always be there, as the moon that is causing them will not always be orbiting around Mars. So here we get to see an eclipse around a different planet. Eclipses are not confined just to Earth, but any planet that has a moon could have an eclipse. And it will depend on how far away that moon is from the planet and how far away the planet is from the sun. That will affect the size, how big the sun appears to be in the sky, and how big the moon does. Now, in our case, for our moon and the sun from our distance, they appear almost exactly the same size. Here we're looking at Mars. We're farther away from the sun, so the sun will appear smaller. But the moon itself is a lot smaller than our moon. But because it's so much closer to Mars, it will still appear in angular size relatively close to the size of the sun there. While it's not able to block out the entirety of the sun, it can block out a good chunk of it at its largest. So a large portion of the sun being blocked out by the moon Phobos as it passes in front of the sun in the image taken by the Perseverance Rover. So that was our picture of the day, titled A Martian Eclipse. Phobos crosses the sun. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.